Welcome to Thursday of week 5. We're going to do a review of, whoops, I'm in the wrong problem. Mortgages. The homework, at the end of the homework for mortgages, asks us to compare other situations to the one we did in class the first time we looked at mortgages. So there was this Wall family. I'm going to tap the screen so that it goes into the PDF file also. And the Wall family was, there we go, having certain numbers about how much they wanted to spend and what the interest rates were and all these other things. So, let's do the last one.
Whichever one. Just one of the doubling or halving.
Yeah. So the last problem will say, the blank page, second. Come on. There we go. Okay, so the last one will say, what happens if we double the interest rate? Okay, so the Calamity family has a calamity. They are buying a house when the interest rates are way too high. Maybe they will be able to refinance later and get out of their calamity. But they're going to do this anyway and have everything else the same as the Wall family, except that they're having a 12% interest rate instead of a 6% interest rate. So if you double that one starting number, does everything else double? So I'm going to go back and get the Wall's numbers. Paste. There we go. Okay, so the family that we're studying now still has $1,100 per month that they want to spend. But now, every time they hand over $10.29, they get $1,000 mortgage, rather than handing over only $6, because the number for 6% and 30 used to be 6. So this number used to be $6 instead of the $10.29. So for that first step, if we do our division just like before, we get about 107. Each of those $10.29s represented $1,000 of mortgage. So this number is 107,000 of home size. So I'll actually write that with enough zeros. And we can see right away, no, that's different. Right? So this one and this one are different. It's not only not double, it's not half either. And that shouldn't be a surprise. 1029 isn't double the 6. So when you divide, you're not going to get half of the 183. So I could already stop and just say no to this problem. If you double the interest rate, it doesn't double the size of the other things. You might actually expect it to have the size of the other things, but it doesn't do that either. Yes?
Just put a little point out which ones they're talking about doubling, because, I mean, which numbers are they saying should be doubled or not doubled?
It's thinking of doubling this one.
Okay, so the home price should be doubled, the 20% down price should be doubled.
But But it doesn't work that way because those are all
Right.
consequences of the other thing.
Yeah.
So the point is to work through the problem each time. You can't just say if we double one, everything else will double. Or if we have something, everything else will have.
So and everything else won't double?
No. I could keep going and figure out what the numbers will be for them, but I've now sort of made a mess of the slide. So. Okay, was that enough to answer your question? Let me just talk through it. So if we did keep going, we'd say what's 20% of this new home size for the down payment, and then we'd either do 80% or subtract away that down payment to find how much the actual loan would be, because you don't get a loan for your down payment. We do what's 3% of the actual loan, which is smaller than that, right, to see what the fee is. You would take the actual loan in thousands, multiply it by the 1029, and see what their monthly payment will be. It's going to be smaller than the 1,100 because I'm not having to pay a monthly payment on the down payment. And I say that, but in real life, again, we often do. We don't have the down payment sitting around just free in the bank account. I'm borrowing some from family and some from my kids' savings for college and some from my savings for retirement, and I have to be paying those back. So I probably, if I'm doing this responsibly, will be forking out close to 1,100 a month. It's just not all going to the bank. So that was that. And then the upfront costs, we could add all those together. So. Okay. Have we done both Brenda and Zane in class? I know we've done Zane.
Yeah.
I don't want to do them both, so I could make up different numbers if we just want to go through this again step by step. Would that be a good thing to do?
61, but not 62.
Okay.
So I just have a question.
Sure.
So for Zane, say,
Mm-hmm.
oh no, 60.
You want
So
me to?
his income is 65,000.
Mm-hmm.
We would times that by 30% to get the answer.
Let me pull up the other slides from the other day real quick, just so that we can be looking at something while you talk. So. When did we do Zane? Here's Zane. Okay. Okay, so he had his annual income of 65,000. First, we found 30% of that, and that would be how much he could spend per year. We wanted a monthly, so we had to divide by 12.
Okay, because I was looking at what confused me is with a 15-year loan.
The 15 and 5%, we looked at the table,
Okay.
and the number where those met was $7.91.
Okay.
So he's going to show up at the bank with $1,625 in a shopping basket. And every time he gives the teller $7.91, he gets $1,000 in mortgage.
Okay.
So we use division. How many times can he do that before he runs out of money? He could do it 205 times. So he should look for a house that's about 205,000.
Okay. Thank you.
The next step was he gets a 15% down payment. So if you wanted a house that was about $205,000, so the 15% of that is this much down payment. We'll take away the down payment. So here's the loan he actually gets. It's smaller because he has a down payment. Again, every time he pays $7.91, that's $1,000 of loan. So he actually had not the 205, but only 174,000. So we take the 174.25 and scoot the decimal point, scoot. That's how many $7.91 he has to pay each month. So his monthly payment turns out to be slightly smaller than his initial estimate, which is fine, because again, he's paying off that down payment in some way.
That makes sense.
His fee is 4%, and it's 4% of what the loan actually turned out to be without the down payment. So multiply by 0.04, there we go. The first month we just found, he had some other expenses that were just given to us, and there was that big down payment. So add them all up, and that's how much cash he has to have if he wants to actually go out shopping.
When I went through all the homework and I printed out the part that gives the directions step by step for my notes because I'm not a real visual learner, and I'm finding that that's really helping me.
Good.
Thank you.
You're welcome. Sometimes it's just easier on the whiteboard to see it spread out better, because the one problem with the website is the HTML doesn't fit on the page in as pleasing a way. Okay, so far it's been only me up here. Should we do a review from 20 problems so someone who wants to do another one at the board can have something nice to do? Okay. Now, right now, you all look busy with whatever else you're doing. Okay. Okay, so percent sentences. Real quick. They have what is of in percent. And when you read a paragraph, there are, 3,000 students at a community college. Currently 8 of them are eating waffles. What percentage are eating waffles? Then you can take a word problem and translate it into a percent sentence. Right? 8 is what percent of 3,000? And so on. So they're a tool to solve real-world paragraph kind of word problems. How you solve them, there were 2 different ways. And we don't have one here, so let's just grab a random one. Okay.
But I cross multiply, is that okay?
You can do either method. I want to try and refine Edwin's power method, but I'm still sort of working on my spiel and diagram for that. So there was a translate way. And there was a proportion way, and then there was the other way that we're not quite ready to do. Oops, why did it jump like that? Okay, so 57% is 35. In the translate way, of means multiply, is means equals, what means why, just like any word problem, make equation kind of business.
Here's a silly question. What is divide?
Usually per,
Thank you.
or sometimes for every $7.91, he gets $1,000 of loan. So I'm going to use these three. Scroll up just a little. Okay. So I'm going to take these three things and use them to translate my present sentence. So of 57%, that one, I'll just go left to right. I don't want to leave it as a percent. I want to make it a nice decimal because that's what my calculator does happy. So am I going into or out of percent? I'm going out of percent. It's already a percent. So out of percent, go to the left, 0.57. Okay, of means multiply. What means y. Is means equals. 35 is a number. It just stays 35. So translate there. Now I have an equation. Something is stuck onto y with multiply. I want to get y by itself. What should I do?
I can't remember.
100 over 100.
No, I want to do the opposite of a times 0.57.
Divide.
So divide by 0.57.
What's that called when you do that?
Doing the same thing to both sides of an equation.
Yes.
Yeah.
Oh.
So whatever that is, 35 divided by... No, it's not. So I'm gonna round it. So about 61.4. Does that make sense? Let's think about our answer. 57% is more than 50%. It's more than half. It's not a lot more than half. So a little bit more than half of what is 35? Does it sound like a bit more than half of 61 is 35? Yeah, half of this would be about 30. So we're a bit more than half to get to 35. That sounds like we're on the right track. If that sort of mental double check didn't work, I might think I hit something wrong on the calculator, which happens all the time.
Okay, so if I didn't write down all those steps, and I know that 57% of what is in the middle, I know to automatically divide the 57% of 35.
Right.
Right.
The thing that Edwin had presented last time, that was almost a good thing, was something like that. If the thing I don't know is the percent, do this. If the thing I don't know is the whole or the part, do this or this. But I want to make it really clear about when you multiply, when you divide, and if you're dividing, which number is in front or the other. It's not always the bigger one. So I need to refine that mini lecture a little bit more before I'm happy presenting it. Okay, so that's the translate method. If you like it, learn it. If you don't like it, don't do it. The other way is the proportion method. Some people love cross-multiplying. This makes them happy. So the proportion... What? You don't have to rip-lop. Yes.
That's the exciting part.
So here's the
I'll do
proportion
that.
method.
I'll do that one on board.
And these four things for the proportion method make no sense at all if I just say them out loud. So I'm going to leave this page immediately and just do them. So the first step is to make the skeleton of a proportion. Fraction bar equals fraction bar. Can't have a proportion without that, so let's get that there. On one side, and by tradition it's the right side, we make a percent. So we have the percent here and 100 here.
You had a volunteer.
Oh, you want to? Oh, okay. I'll let you take over.
Thank you. Hardest part of your brain.
I hate stuff
No, but
like
it's part
this.
of your plus.
Oh, okay. So practice.
Okay, so we have 50%. of what
Or is it
equals
once?
4 times.
equals 35. So we know that 57. How do you? Okay. What?
Click on the little pencil thing up at the top.
Oh, okay. Where? Oh. Should I do it?
No.
It's not working.
I turn it off. There, I booby trapped. Okay.
Okay, so we know 57%. So 57. Oh my gosh. Goes over 100. And then from your example, anything after the word of, it always goes in the lower left-hand corner. So I use N for number. Is that okay?
Sure.
Okay. And then we have the last number, which is 35. I cross multiply because I don't like riplop, and I just made a mess. This is harder than it looks, guys. So N and times 57, I just put N 57, equals 35 times 100. And then N 57 equals 3,500. And, sorry, N 57 over 57, because you want to do what you do to one side, you want to do to the other. Fancy terminology. 57. So then just get rid of those. So it's 3,500 divided by 57. Should I write that? Or okay. Equals 61.4. That is so much easier for me. I don't know why. I think it's because you pointed out in that last one, I've never heard the of goes down to the lower left.
Yes.
What did you do?
I am going to label that this is the percent. This is the 100. This is whatever comes after of. And then when you're all done with that, there's something left over that. Oh, come on. Here you go. Is your last item. Okay. In the last step, she divided both sides by 57. 3,500 divided by 57. Just fractions are just division.
So the other two on the N57, that gets crossed out.
Right, because 57 divided by 57 is just 1, so that goes away.
So then you just have to, one, yeah, thank you. That just makes the most sense to me. I don't know if
Okay, so that's our whirlwind review of percent sentences. If you need more, look at past lecture from last time. And then we did it earlier in the class too. I don't remember which day that was. But somewhere. Now let's talk about interest. Okay, I'm going to start all over. Pretend we didn't do this last time. A few people were running out of the room at the end of the class, and someone wasn't here, so we'll just do things again.
And that was mortgages that we just did, right?
No, that was percent sentences. Mortgages we did earlier with Zane.
Okay.
So this is our third topic for the morning.
Okay.
There is a lot more if people are hungry. So interest is a fee. It's a fee that someone who lends charges someone who borrows. If you have a savings account, if you buy a government bond, you are loaning money, so you get the fee. If you have a credit card, you are borrowing money, so you pay the fee. The initial amount of a loan is called the principal, the same word we used for mortgage loans. A loan with the least math would borrow money for just 1 year, and at the end of that year, pay back the loan and the fee that's charged. So, if we asked what is, what is 12% of 100? Just because of space, I am going to translate. But again, if you like proportion method, that's great. Then you can say, the fee for this loan would be $12. So at the end, we'd have to pay back the 100 that we borrowed. Wouldn't be much of a loan if we just got to keep that. And the $12 of the interest. Okay, so there we go. 12% added on the end. We're paying a fee because we borrowed money. It gets more complicated than that, of course. First of all, let's use a trick. Before it gets complicated, let's talk about the trick. We had to add back on that $100 of principal just a moment ago. It would be easier if we didn't have to do that step and someone just had some way to make it all appear the same. So we can do that. The 1 plus trick says that if instead of multiplying by 0.12, multiply by 0.12, if we changed that to having it be 1.12, then two things are happening. The 0.12 times 100 is making the 12, just like it did a moment ago. The times 1 means that the 100 is sticking around, because times 1 doesn't change anything. So we wind up with the 100 from the times 1 and the 12 from the 0.12 at the same time. So, there we go. Times 1.12. We're taking the percent we're multiplying by, we're sticking a 1 in front, and that keeps things around. So as another example, if instead of 12% it was 8%, oops, and we had $1,000, and I wanted to know what would be owed at the end of the year, I could say not a 0.08, but a 1.08, and I would get my answer right away. Everyone okay with our trick? Sometimes that will help us, sometimes it won't. Sometimes the problem asks us what's the interest only, and sometimes it asks us what's the total amount.
Well, and on the first one you did, the 1 is added to the left. On the second one you did, the 0 is added to the right.
0.
You know what I'm saying?
No, you've lost me. Tell me again. So on this one,
Okay, on the first one you did, when you did the plus 1, and it became 112.
okay,
The 1 went off the left-hand side.
right. It still did. Right, this one.
Oh, okay. So it's not the end answer we're looking at. We're actually looking at working out the problem, and instead of 12.12, you added the 1 in front of it. And instead of 0.08, you added the 1 in front of it. Okay.
Yeah, the fact that this looks like this is only because we had a century frenzy 1,000 here.
That's not something we have to use, right?
The 1 plus trick.
Yeah.
You can do 2 steps, but we're going to use it in a moment talking about compound interest. just to make something else work. So 2 steps is really not that big a deal. Okay, so far our story has had the simplest case. A certain amount was loaned. There was a fee. The loan lasted a year because the fee was a yearly fee. So what happens if the loan has multiple years? So for this type of loan, it's going to remain true that the fee is only actually paid to the person who gets it once. At the very end, the end of the loan happens and they say, here's your original money back, and then here's a fee. But the fee is going to be bigger because more years go by. So we're going back to our earlier case. We still have the 100 times the 0.12 is $12, just like before. That's per year. But now we have 5 years. So we need 5 times the $12 is $60. Now our fee, our interest, is 60 instead of 12, because we've had 5 times as long. So then how much do we pay back? We still have to pay back the original principal. We now have 60 of interest. So there we go. If you buy a government bond, that's how it works. You don't get money every year from the bond. You have to wait till the bond matures, and then you get money. But the more years it is, the more you get back. It used to be that banks would have certificates of deposit that were simple interest. These days, there aren't as many banks using certificates of deposit, and a lot of them are compound interest. But some banks still actually do simple interest certificates of deposit too.
So this is actually looking for the total interest at the end of the 5 years.
Yep.
Because I was thinking what you would have to do is, I was thinking what would the payment be monthly?
Yeah. No, you're thinking of credit cards, which is different than these are government bonds or things like that. So we're about to get to yours. Okay. So, whoops. Now, what happens if the loan lasts less than a year? There's 2 things that we could say. We could think, too bad, that's the fee. It's a 1-year loan. If you pay it back early, that's your business, but you still owe me all the fee. That would make sense, but that's not a happy customer. That's bad for business. So instead, everyone says that if you pay it back early, you only pay a certain amount of the fee. If you pay it back after half a year, you pay half the fee. If you pay it back after a third of the year, you pay a third of the fee, and so on. So whatever the time is, if we change it into years, or a decimal amount of a year, then the fee gets smaller too. So let's do 2 more examples. Now let's take the 100, multiply it by the 0.2, even though we've done this so often. So if it was a whole year, we'd pay 12, but it's not. Instead, it's 6 months, so half a year. So we're going to take the 12 that we just found, multiply it by a half, divide it by 2, times 0.5, whatever makes you happy, right? And we'll get $6 because that's half of 12. So when we pay things back, it would be 106. In this case, the problem is trying to trick us. It only asks about the interest, so I'm done. Put a box around the answer. If they asked us the total, I'd have to put the principal back, as we've been doing before. Okay, half is a friendly number. We could do something a little worse. A $2,000 loan lasts for 200 days. It has a 20% annual interest rate. How much will we do? So for the whole year, it would be the 2,000 times the 20%. 2 times 2 is 4. Move your zeros around. So what am I going to do now?
Fractions.
So
200 over
200.
365 and
Yeah.
400 over 1.
So I take that 400 and I'm going to multiply it by a fraction of 200 over 365. Any fraction is just a division problem. We saw that a moment ago at the bottom of Kim's working out things step by step. So if you don't like how this looks, then instead make it say 200 divided by 365, like that. That's good. If that makes you nervous, you can put parentheses around here to say that's one little thing. And if historically that's where those numbers came from, they used to be a fraction. But the parentheses aren't going to do anything to the calculator because we're just going left to right with order of operations when everything is multiplying and dividing. So I can get rid of those.
I thought if we were doing it like that, we would have to go from left to right.
Yeah, we do go left to right.
So we do 400 times 200 and then divide that by 360.
It's going to come out the same, actually.
Oh, really?
Yeah. Because what I'm really saying is that here's one thing and here's one thing, and it doesn't matter what order I multiply them. Because multiplying doesn't matter what order I do it. Okay, so what is this? 400 times 200 divided by 365, so about $219.18. I shouldn't be quite so cavalier with my order of operations. If the division sign was in the middle, it would mess us up, and we need parentheses, but it's at the end on the right, so we're okay. So if you notice, we're multiplying. First, we're multiplying the principal and the rate. That gets us our annual fee. And then we're multiplying by more years or part of a year or whatever the time is. So all that multiplying we can write as a formula. This isn't some formula that really came out of a pattern the way the BMR and DCI did. Instead, this is a formula that is just sort of observing what we're doing. We're taking the principal, we're multiplying it by the annual interest rate, and then we're doing however many years, whether that's 1 or 5 or 200 over 365 or whatever it is. If you haven't memorized the simple interest formula, I would recommend writing it out in words because that's the clearest. But because everyone in the world loves acronyms, then it's often written interest is principal times rate times time, P times R times T. That's a little trickier. You have to remember that the I for interest is simple interest. That's what we're doing where there's just one payment at the end. You have to remember that the rate needs its rip-lop to happen to it. We're putting a decimal in. And you have to remember that the T is years. If they give you days or months, you have to fidget with it to make it years.
Trip. Might be a way to remember it.
I've heard. It's pretty PRT.
Times T is the year.
Right, T is the years. Okay, I will lock that into the PDF. So this picture shows what's happening. There's a principal, and then every year we're sticking on the same amount of interest. So the amount of interest is growing at a very steady linear rate. Okay, let's do one more. And And I'll save the others for Tuesday, because you know enough to start on this now, and I want to do compound interest also before we're out of time. So, $100 loan lasts 18 months. It has a 3% annual simple interest. What's the total amount of interest?
450.
One thing that some people do, are the dots big enough in the back, by the way? Don't like how I can't make my dots bigger. Okay, one thing that some people do is they say, I'm going to write the formula, and then I'm going to list out what all my letters are. Because if anything funny is going to happen, it's not going to happen when I plug things into the formula. That's when the calculator does all the work. It's going to be in the setup phase. So in this case, the interest, that's what I'm solving for. My principal is 100. My rate is 3%. So that'll be 0.03. And my time is 18 months. So how do I change that? Everyone okay with my blue setup stuff? You're not required to write out the blue setup stuff like I am, but I recommend it, especially when you're sitting down over the weekend to first start the homework. Once you get into the swing of it, it'll be easier. But this is where people make mistakes. This is where your brain turns off on a test, so on. So, okay, now it's all straightforward. This was 100. This was 0.03. This was 1.5. And the calculator is doing all the work. Okay, 100 times 0.03 times 1.5. We're done. If you're awake and not distracted by things, then this would be easy. 3% of 100 is 3. 1.5 copies of 3 is 450. But the chance that it'll go that smoothly in your brain on a test is
The
kind of
one
cool.
before that, we did multiplication and then division, and this one we're doing multiplication and multiplication.
Because the 1.5 didn't need any division happening. Before it was so many days out of a year, the 200 over 365.
Oh.
Whereas here, the 18 months, we could just say, that's a year and a half.
Mm-hmm.
I could have written it as a fraction. There'd be nothing wrong with saying, one moment, new copy of everything. Okay, so there'd be absolutely nothing wrong with saying this is 18 over 12 of a year. And then here, doing 18 over 12. Hey, that's great. Nothing wrong with that. It's just not what my volunteer on the side said. Okay, so that's simple interest. Formula, 3 things, plug them in. Appreciation and depreciation we'll talk about next time when I see you on Tuesday. That will be a good way to review this with a different setting. For now, we're going to do 6 years of rent increases. There's an apartment. The monthly rent starts at $500. Every year, the monthly rent goes up by 5%. So for the first year, what's 5% of 500? Of means multiply, remember, so 0.05 times 500, we got 25, we added on. What's going to be the starting amount for year 2? The same thing we just had, right? So that's what we have to start with now. the 5% increase is not going to be an even 25 anymore. 5% of a bigger number will be a bigger amount. 5% of my salary is a lot less than 5% of Bill Gates' salary. So if I do 0.05 times 525, now I'm up to 2625. And I can add those. And I'll do what? 551.25. Is my brain working right?
Yeah. No. Yeah.
So that's what we'll start with next time. Okay, work by yourself with your neighbor. Finish the table. Make sure you're understanding this increase 5% thing. Okay, hopefully people beat me to that because I stopped for a while. Do your numbers match mine? Did I make any mistakes? I can check my pop-out answer key. Yeah, okay. So we could say things like, what was the rent at the end of the last year? It was $6.75. Or we could ask, why does the amount of increase keep changing? And this keeps going up. This number keeps going up. 5% of a bigger number is bigger. We could ask, what's the overall percent change? So the percent change formula is change over original, change divided by original. Remember that one we've used before? So how much change was there overall? From 500 to 670.05, that's going to be 170.05. So it's about 34%. 34% is kind of weird. If I have 5% 6 times, you would think that would be 30%, because 5 sixes is 30. Where did the extra 4% come from?
Every time you add it more.
Yeah, it's not 6 copies of 25. It's 6 copies of things that get a little bigger, so that's where the extra 4%.
So what if I rounded it wrong and I got 638.24 instead of 638 14? I got lost in there
Somewhere. I'm not going to figure it out now, but I can.
Okay.
After class we can look if you want to see where. It was a calculator press somewhere, but we just did so many calculator presses, I'm not going to worry about any particular one of them. Okay, that was too much work. Remember that 1+ trick we did earlier today? We could have just done that. 500 times 1.05 is 525. Or the 525 times 1.05 is the 551.25, and so on. Any of these rows, we could just do that. Does that make sense?
Yeah, it does, and I found it.
You found it. Great. Okay, so that was nicer, but we actually don't care about any of these numbers, right? They're just sort of the progress. What we really cared about was the number at the end. So, when I'm doing my 1+ trick, I know that this number is 525, but I don't care that it's 525. I can still write it as 500 times 1.05, because that's also what it is. And similarly, I'm going to get some number here, the 551.25, but I don't care what it is. It's just also a 500 times 1.05 times another 1.05. So I can write it, whoops, that's not an arrow, that way, 500 times 1.05 times 1.05, that's what the exponent is. And similarly, I can say, I don't care what this number is, it's just going to be times another 1.05. I don't care what that number is, it's going to be times another 1.05, and so on. So this is where we get our pattern, that it doesn't matter how many times I do this. If it was year 10, it would be 500 times 9 1.05s from everything before, and then the 10th one, the 10th year. So we can write a nice pattern of that. So this is just going to say that y is our 500. Let's make that look nice. We've done a lot of work to get to here. Okay. Times the 1.05 n times. Everyone happy with that?
Yeah. Isn't it n minus 1 though?
No, because you have one more for the year that just happened. The first year we had 0, and then we added 1. The second year we had 1, then minus 1, and then we added the second. If we had 2, and we add 1 more. So it's 1, 2, 3, 4. That makes sense? Okay. Don't focus on the blue, because we have another one coming. So what we just did is reinvent the compound interest formula. So let's look at that. No, come back here. The English word compound means two different things. It could mean an item made up of lots of parts, like a medicine that's a compound of ingredients. Or it could be when something is made greater by a certain kind of things. The strong winds compounding the difficulty of putting out a forest fire. And compound interest is both. Bigger, different things are being put together, and they're making this exaggerated effect. Where that extra 4% came from. It wasn't 30, it was 34. So, compound interest is not a math decision. It's a type of loan. When you get a credit card, they say it's compound interest. They got to pick that. They could have done simple interest, but they want more money. So we don't ever have to decide which kind of interest, which kind of loan it is. That's part of the problem. But whatever the problem tells us, we have to use the right formula. So here's how it looks. The first year, we paid the 25. The second year, we paid the 25 and an extra 5% of the 25. And the next year, those keep around. And there was 2 greens to build off, so I get another purple. And this new amount gets summed too, and so on. So it's not a straight line anymore. It's bending up and up and up. Whoops, why is there... Oh, because that's where I stole the picture. Okay. So here's another example. If we had a credit card, something people think about more often than rent increases, a 22% annual interest divided by 12, the monthly would be 0.01833 and so on. Use the 1 plus trick, put the 1 in front. And we could do the same thing we just did, but with sort of credit card size numbers. And this is going up and up and up and up, faster and faster. Writing it as a formula, oops, let's shrink it so it's not on 2 lines. Then we have, I'm just going to let it wrap, I don't want to shrink it too much. That the final amount equals that principal times the 1 plus trick, 1 plus the rate per payout, and then as an exponent, the number of payouts. Looking at what we just wrote a moment ago, our final amount, which includes both paying back the principal and the interest, is the principal times 1 plus the rate per payout. Exponent is the number of payouts. That's exactly what we did. And we're not going to have time today for example problems, but we'll do a whole bunch of this next week.
Well, thank you for that, because where the N is, I would have gotten confused and would have been like, what was the N supposed to be? But it's the number of payouts.
Number of payouts. And the one we just did, the payouts were once per year. And the 5% was once per year, so it was fine. We'll see in a moment that with the credit card one I just showed you, this was not 22%, but 22 divided by 12. And this wasn't however many years, but the years times 12. So there'll be little bits of setup to do. And that's why I showed you a few slides ago that when you are given a formula, we'll write out the formula. We'll do this again and again and again next week. And the rate per payout, we're going to have to do a little fidgeting because it'll be per month or per week or something. And the number of payouts we'll have to do some fidgeting. Because it will be 5 years, but then that's 5 times how many weeks, or 5 times how many months, or whatever the payout thing is. Credit cards are monthly, but there are some stock dividends and things that are quarterly, so it's not always monthly, and so on. So we'll play with that. So this isn't harder, it's just going to be another formula, you plug things in, but it's not quite as easy because you have the blue setup. That wasn't there for, say, DCI. Okay, have a good week.
I tried 30 years on paper. I just